Okay, this is continuing 7.1, and this is about a polygon circumscribed about a circle. Very similar to the one we just looked at, where the circle is inscribed inside of a polygon. But one of the things that we can see here that I've created is a polygon outside of a circle. A couple things to notice. One, all sides of the polygon are tangent to the circle, right? So they come over here, I can see, and I've created these so that there are tangent lines, and the polygon that I'm talking about essentially is the one that goes from G down to E down to F, and that's of course a triangle that is circumscribed about a circle, and the circle here is a radius 3. A couple things also, all radii drawn to the points of tangency are therefore perpendicular to the sides of the polygon. So if I went in and actually created, I'm going to make sure that I've done this angle. So if I figure out an angle and go from here to here to here, I get that 90-degree angle there. And that will be preserved no matter what I do, because that's how tangents work. And we'll talk about tangents in the next section in 7.2 as well. But for our purposes, the polygon being circumscribed about the circle will result in these 90-degree angles right here, which is really helpful since we've spent a good deal of time talking about right triangles. And there are some right triangles in here, and there's a question after this video about that. And so again, here I've said sometimes right triangles emerge, and we should look out for them. There is one here that we can even take a look at, G to A, and so we have a right triangle over there, and that's nicely preserved no matter what happens. All right, so there's some questions coming up later on about what happens with those right triangles. Quickly, if I want to create another, it doesn't have to be a triangle. It could be any kind of, let's see, whoops, what did I do here? Circle with center and radius. I have a point. I want the radius to be 3 again, let's say. I can erase this other one because I don't really need it. And then what happens is we take and we put points on the object. So there are a couple here. The picture is going to get a little messy, but you'll get the gist of what's going on. I've got a bunch here, and let's create tangents at those points. So we have to tell it to put a tangent at that point and the circle. Tangent and circle. Tangent and circle all the way around the circle. And then we can go in and find out the intersection points. So there's an intersection point here and here and here, there and there. We could change the colors if we had time to do that. But let's actually instead look more at the segments that are created. So there's a segment here to here. Oh, and they're orange this time around. This is kind of fun. So here's a polygon circumscribed about a circle. And again, if I change where the point is, of course it changes the size of this polygon, but we essentially have a 1, 2, 3, 4, 5. So it's a hexagon, not necessarily a regular hexagon, but a hexagon circumscribed about the circle of radius 3. And again, to make the point clear, we have these radii in here. And if I wanted to maybe change the color of those, that might be more helpful. Hopefully that'll, oh, there we go. So all of these are of length 3, because that's how I created the triangle. And we have, of course, all of the angles are 90-degree angles. Make sure I'm doing this the right way. There's the 90 as well, and a bunch more all the way around. Okay, and so there we have it. And that's what happens. We have to be looking out for 90-degree angles we need to remember that the point of tangency is always perpendicular to the radii, and that the sides of the polygon are always tangent to the circle, and we'll talk more about circles coming up later. Okay, thanks. That's 7.1, polygon circumscribed about a circle.